Hey guys, welcome back to the shop. We're going to continue on our desktop gyroscope build. I wanted to video everything, but my camera was out of batteries when I split these rings. And I also did some layout and some drilling on the inner gimbal rings here. I punched the holes perpendicular to each other in these. And then these, I put the hole here, which is going to use for our mount on our base, which will mount on the stand. And then I just cut it in half on the bandsaw, marked it and cut it in half. But we need to lay out the second gimbal ring, similar to the inner gimbal ring. It's going to have two holes drilled through it, and then on the outside diameter we're going to have to mill in some recesses, and that's where we're going to put our bearing in that is going to ride on our outer gimbal ring there. So we need to lay this out, and we need to get some marks on the outside here perpendicular to each other. So the way we're going to do this, first we're going to add some layout fluid here so we can see where our marks are. This will take a minute to dry. Basically, to divide up a circle, there's a formula you can use. So if you wanted to divide a circle into 4 parts or 5 or 6 or 7 parts, you can do that. And the way you do it is this formula here. It's going to be this here. So the degrees is going to be, that's going to be determined by how many parts we want to divide our circle in. And then we're going to divide that by 2, take the sine of it and multiply it by 2. And then we're going to multiply it by r, or the radius of our circle. So in this case, the degrees, we're going for 4 equal parts. So we're going to have 360 divided by 4 is going to be 90. So our degree value is going to be 90. So if we divide our degrees by 2, that's 45. And if we take the sine of that, we get 0.7071. And we're going to multiply that by 2. Is 1.414 is our multiplier. And this is what we're going to use to multiply by our radius. And we're going to set our dividers at that resulting value, and then we can step around the circle. So our diameter that we're looking for to step this off is going to be 3.755. So if we set our calipers to 2.654. Okay. And then we're going to go ahead and set our dividers to that width. And then what we can do is basically walk off our circle. So we'll put one tip of the divider just right on one of those scribe lines, and we'll just walk it off. So the first point's going to be right here where it intersects our scribe line. And we should be right back to where we started here. I forgot to mark that. Just make a little cross there so we know right where it crosses. Yep, we're right on. Okay, so we're going to go ahead and tap this inner gimbal, the 2 holes that were drilled in there. This is going to be tapped 3/8 by 24, and I have a little fixture here that I built specifically for this. It's just a little piece of aluminum rectangle with a little threaded bit in here and then a brass rod that's sticking up. And the idea is that we can fit this down on here, and then we can verify if we need to make any adjustments that the hole that we're tapping is lining up with the bottom hole. And that way the piece that we, when the rotor's inside here, the shaft should be aligned between the bearings in there. Let's go ahead and tap this. Okay, back this out here. Alright, so that looks good. I'm going to take this off, and then I've got a second insert. I can thread in here. That is threaded 3/8 by 24 on this side, so we can go ahead and thread on the piece that we just tapped to hold it while we tap the second hole in the top. Okay, there it is. All right. And we're just going to go ahead and take our chamfer tool. Chamfer these edges. Alright, we're back over here at the lathe. I got some 1-inch just mild steel chucked up, and I'm going to make just a little shaft or an arbor. I'm just going to thread the end to fit our aluminum bases on so that we can turn the OD and finish those bases up. So we just need to turn this down a little bit to 7/16 by 20, which to thread 7/16 by 20 we need 436 thousandths diameter. So we need to take off about 570, 565 or so. So we're going to face this off, and then we'll turn this down, and then we'll thread it. Alright, there's our face. And then we don't need too much, maybe about a 1/2 inch, 600 thousandths, something like that. And we'll go ahead and try 100 thousandths pass. I'm not going to use coolant because it's going to go everywhere, but we're going another 100 thousandths. Actually, we'll do 140. Alright, let's see. 442. So we need 6 thousandths. Okay, that should be our diameter. This is our Tailstock Die Holder. It's just a shop-made tool that I put together. It makes it nice to use dies on the lathe that holds them nice and straight. This we're just going to run by hand. Until we get it started. Applying some pressure with the tailstock until it starts, and then we can just use our handle. Okay, we've got our threads. And let's go ahead and test one of these on here. Cool. So we'll thread that on, and then we'll throw a center in the tailstock. And then we can go ahead and cut our OD here, which we don't need much off, just to clean it up so it looks nice. Alright, so we're going to feed this. Perfect. Looks nice, feels good. Alright, so that's our base, that's all finished up. On to the next. Okay, we're over here at the mill, and we're going to mill out the recesses to put our bearing in on this middle gimbal. And so what we're going to do is, it's going to be kind of hard to see, but this is about the best setup as I can do. I have these rings on a chuck being held here, and then I've got a jack underneath to give it some support, and this seems to work fairly well. It's kind of hard to hold these upright with the setup that I have here on this mill, but basically is what I'm going to do. Our bearing is 139 thousandths thick, so I've got the indicator zeroed out when we're just touching. So we're going to go ahead and mill out about 140 thousandths deep. Alright, switched out the end mill. We've got our 1/4 inch in there, and we're just going to go down maybe, I don't know, about 15 thousandths or so. So we'll set our 0. Alright. I went ahead and went 20. If we can focus in on that. There we go. So here's our 5/16 by 1/8 inch bearing. Great, that'll fit in there just like that. I've got our middle gimbal ring, and we need to center drill 4 holes that we marked out, and then we need to drill those so we can tap them 3/8 by 24, and then we're going to turn some brass inserts, some shafts basically, that are going to go through this ring and sit into the bearings of the inner gimbal ring, and then on the opposite end some shafts that are going to go out and mount to the outer gimbal ring to allow this one to spin and the inner one to spin the other way. Alright, we're done punching our center holes. We'll go ahead and change out to our tap drill. The tap drill is actually 21/64. I just made I don't have a collet for that, so I just made a little brass bushing that fits in a 3/8 collet in order for us to use this drill bit in there. And seems to work great. Alright, those are done. Next stop is to tap these 3/8 by 24 and turn some brass parts for it to fit in there. But we're good for now. Go ahead and chamfer these, deburr them, we'll be all set.